Very good morning, dear students. So, in this session, we will be learning about the various performance tests conducted on the internal combustion engines. First, let us see what is the purpose of testing an IC engine. So, there are various parameters to be determined by conducting an experiment or certain measurement on the internal combustion engines, whether it is SI engine or CI engine. So, first one being the determination of power output, how much power an engine can deliver with respect to the fuel given in kilogram per kilowatt hour. Then determination of mechanical and thermal efficiencies, so efficiencies of various efficiencies of the engine. So all these things, if you want to measure, we need to run the engine at a specified rated speed, and by measuring so many parameters like fuel consumption, speed, um, the brake power. So various equipments are there to measure these parameters that let us see one by one in detail. Then the third purpose for conducting various tests on IC engine is to see the performance of the engine when loaded at different loads. So always the engine may not run at the same load. The load will vary, right? If you take the case of a vehicle, sometimes only the driver will be driving the vehicle. Sometimes entire passengers will be there. Sometimes extra load will be there, right? So depending on that, you might have seen that even the tire pressure should be altered in order to get a particular um, comfort in traveling. So similarly, the performance of the engine, that is the efficiency and the output, all the things will be varying, and how these things are varying at different loads, that could be determined using specific experiments. Then to determine the quantity of lubricating oil required. So you know that there are various moving parts within the engine: piston, cylinder, connecting rod, crankshaft, right? So everything, since these are mechanical moving parts which are in contact with each other, lubrication oil is required. So quantity of lubricating oil required per brake power kilowatt hour. Then to determine the quantity of cooling water, since enormous heat is generated within the engine cylinder, so you need to cool the cylinders, right? So how much cooling water is required? Then determine the overload carrying capacity of the engine. If the load is exceeded the rated load, what will happen? Then to prepare the heat balance sheet out of the total fuel given to the engine, how that amount of fuel quantity is utilized. Most of the fuel will getting lost as heat, thermal load. Then some will be going through the exhaust, only a part of which will be converted to the useful power output. So that could be rightly tabulated and evaluated using the heat balance sheet. So these are the various purposes of testing an internal combustion engine. Now let us see some of the important terms before going into the various tests. So first one is indicated power. So this is the total power developed in the working cylinder within the engine. So you know that there will be single cylinder engine, multi-cylinder engines, right? So within the engine cylinder, how much power is developed? That is termed as indicated power. Now, whatever power is available at the drive shaft of an engine is termed as brake power. And the difference between these two is the frictional power. Indicated power, when transmitted to the drive shaft, there will be losses because there are a lot of mechanical components. So in order to overcome the frictional resistance, there will be some loss of power from indicated power. So that is lost as frictional power. Now, specific fuel consumption is the quantity of fuel consumed per unit of power per unit of time. So, how much quantity of fuel is to be consumed for generating a unit of power per second? That is termed as specific fuel consumption. It is generally expressed in grams of fuel consumed per kilowatt hour or brake horsepower per BP. Now let us take the if you state the conditions as standard operating conditions with regard to engine is taken as the pressure is 736 millimeter of mercury and intake air temperature is taken as 300 Kelvin or 27 degrees Celsius. Now the various efficiencies of an internal combustion engine are mechanical efficiency is the ratio of brake power to the indicated power. Brake power to the indicated power. Then indicated thermal efficiency is the it is defined as the ratio of heat converted into indicated work to the heat energy supplied. So out of the total heat energy supplied in the form of fuel, how much is converted to indicated power within the engine cylinder? That is indicated thermal efficiency. Now, the brake thermal efficiency is the ratio of heat equivalent to brake power to the heat energy supplied. So, out of the total heat energy supplied in the form of fuel, how much is the brake power produced by an engine? Now, to summarize the various terms, let us see the various mathematical expressions for these various terms. So, brake power is usually expressed as 2 pi nt by 60. BP is brake power, N is the speed of the engine in revolutions per minute, T is the torque in Newton meter. IP, indicated power, is usually expressed as the product of indicated mean effective pressure. PIM is indicated mean effective pressure, L is the stroke of the piston, A is the area of the piston, N is the revolutions per minute, rotational speed of the engine. K is the number of cylinders. N will be equal to N by 2 for 4-stroke engine because for every 2 revolution, 1 power stroke is obtained from 4-stroke engine. But in the case of 2-stroke engine, for every revolution of crankshaft, you will get 1 power stroke. Mechanical efficiency, as we have seen earlier, is the ratio of BP by IP. Then frictional power is the difference between indicated power and brake power, and mechanical efficiency thereby we can write like this also, brake power divided by brake power plus frictional power. Now, mean effective pressure PM is usually expressed like this from the previous expression, indicated power into 60 by LINK. Already we have seen the expression for IP. So from that we can reduce the expression for indicated mean effective pressure also. Specific output, sometimes you may have to come across this term specific output. That is a ratio of brake power to the movement of the piston, that is stroke multiplied with the area, swept volume. AL is the swept volume. Volumetric efficiency, one more efficiency is there. Volumetric efficiency is the ratio of mass of charge actually sucked in. What is charge? Air fuel mixture. Air fuel mixture actually sucked into the engine cylinder to the mass of charge corresponding to the cylinder intake P and T conditions, pressure and temperature conditions. Already we have defined the standard operating conditions. If that standard operating conditions were maintained, P and T, how much charge would have been taken in? So not always the standard operating conditions are maintained, right? Sometimes it will be different at different conditions of operation. Now the fuel air ratio is the ratio between actual fuel air ratio to the theoretical or stoichiometric fuel air ratio. Similarly, the brake specific fuel consumption BSFC is already we have defined. It is the amount of fuel consumed per brake power produced. So ratio of m dot f and BP brake power is brake specific fuel consumption. Now the brake thermal efficiency already we have seen, it is the ratio of brake power, how much brake power produced for the given fuel input. MF is the mass flow rate of fuel and CV is the calorific value of fuel. So with that, we will stop for today, and we will continue the various testing and measurements of various parameters of the engine in the upcoming class. Thank you for watching. Have a good day.